Okay, well, our next speaker is getting ready. I'll introduce him. This is Zhou Wang, a Chief Science Officer of SSIM Wave, and he's also a professor at the University of Waterloo. He will be talking about AV1 versus HEVC, a perceptual evaluation of video encoders. Okay.
Thank you. So we just got two fantastic talks about HEVC and AV1, but now I'm talking about AV1 versus HEVC. Okay, so in the past few years, HEVC has been becoming extremely popular, and at the same time, and there's more and more attention about AV1. So naturally, people would ask questions. So how we compare AV1 with HEVC? So basically, these are the questions we care about, right? So first, does AV1 outperform HEVC or AVC on bitrate savings by how much? Second question, does the bitrate savings change with video resolution? And third question, does the bitrate savings change with content? And also, we care about how does AV1 compare with HEVC in terms of computational complexity? And in the end, we also care about which video quality metrics we should use to evaluate video codecs. So these are the questions in our mind, and then we did some testing. We did a study on this. So these are the basic testing conditions. So with encoders, we have AV1, HEVC, and AVC. So AV1 is open source, and we also use X264 and X265, the open source encoder to perform the comparison. And of course, we could use HM and other JM, HM, the other versions for 264 and 265, but here we believe 264 and 265 are relatively mature product people are using in the real world. Actually, this is actually the starting point when we started to work on this comparison. Actually, at the time we actually started the comparison, we also decided we're going to add two more encoders. Actually, that's VP9 and AVS2. And we did some comparison, even though today's talk is going to focus on these three. And for those of you who are interested in knowing the other two, actually, this AVS2, the Chinese standard, is performing pretty well. So it's surprisingly that in our recent tests, it's giving pretty impressive performance based on our study. So if you're interested, you can look into that. Okay, so for the configuration, we're using one-pass encoding for target CRF, and we are using very slow preset, and with all the default settings. And in terms of evaluation, we use SIM+, VMAP, and PSNR to do the objective quality measurement. We have also been doing subjective testing. We believe in the end we want to do subjective testing with all the encoded files to verify the result, even though the subjective testing is still ongoing because we have too many files, too many videos to evaluate, and each video needs to be watched by many subjects in order to get a fair mean opinion score. Okay, so these are the testing videos. Basically, we got 20 10-second video clips, and we select clips such that it covers a wide variety of content in terms of content type. Right? So we have TV shows and movies, and we have animations, cartoons. We have screen content, news, sports, event, right? So all kinds of content, and we also test three different resolutions because we're interested in knowing that how these encoders performs across different resolutions. So we picked three resolutions: UHD 2160p and Full HD 1080, and also we picked 540. Even though that's not a very popular resolution, but because of it's half of the Full HD, so it's easier for us to observe how the encoder behaves when the resolution is got reduced. As I mentioned, we tested 5 encoder types, and each video is encoded with 4 quality levels. And in the end, we end up with 1,200 test videos. As I said, that 1,200 is quite a big number if you think about doing a subjective testing on this video, because you need at least 20 to 30 people to watch the video in order to get a decent number for mean opinion score. Okay, so that's basically the test condition. But before I'm gonna show our results, I just want to mention a few things. First, this is an independent study. We're not part of the group of HEVC or AV1, and we're not selling a product, encoding products. So this is an independent study at University of Waterloo and SimWave. Also, we try to do fair comparison, even though we think this is pretty hard to do, right? So we try to do fair comparison by matching the settings as much as possible. So we select a very slow preset, and with all the default settings, we're not changing things there. And also, I have to mention that the results, you cannot say this is going to be conclusive. The reason I say that is that simply because standards only define decoders, but here we can only compare encoders. Encoders, there are so many variations, there's so many things you could work on to improve that. You have endless things to work on in order to get better and better encoders. So in the end, no matter what you get, after you evaluate certain encoders, you cannot make conclusion on the decoder, right? So that's the reason, no matter what kind of study you do, you will probably never be able to have a 100% fair comparison on decoder on the standards, right? So this is just a relative information for probably useful for practice. Okay, so the first question, does AV1 outperform HEVC and AVC on bitrate savings, and by how much? So in order to do that, that's the thing that the previous speakers have been showing, that we need to draw this, do this RD analysis, or in this case, we're drawing rate quality curve. In this case, we're using SimPlus as the quality measure. So on the right-hand side, you see the picture. That horizontal is the bit rate and vertical is the quality level. And then for each encoder, you can operate them at different bit rate and get different quality. Then you can draw a RD curve, right? So then with 2 encoders, you draw these 2 RD curve. Then basically when you say how much bit rate savings you can get, it only makes sense when you say they achieve the same quality. Otherwise, it's not going to be fair comparison. So basically, you draw a horizontal line, and then the red arrow there shows that how much rate savings you can get. Then you can convert that into percentage, right? So after we have done this, and the lab is the result we get so far, right? So we have 3 tables, each with a different resolution. And then you can, from this, you can basically see that if you compare AV1 and HEVC, that you basically have 28%, and 32%. So it's on average something like 30% savings if you compare this particular, I would say this particular implementation of the AV1 and HEVC encoder. That's what we observe. So, and another thing is, does the rate savings change with resolution? So basically, then you can look at the table and draw a curve for, in this curve, that horizontal is going to be the resolution and vertical is going to be the rate savings. And then you can see about right the general trend that's as expected, actually as expected, that the rate savings is improving when you have higher resolution. Actually, if you draw another curve for HEVC versus AVC, that trend is even more obvious. Right, so that's another conclusion. Generally, if you get a higher resolution, you are expecting the savings are going to be increase. Right. So, and this gives you a particular example. You can pick one of the content out of the picture. Right. So in this case, you have the same content. You have 540p, 1080p, and UHD, and then you look at the rate distortion curve for different encoders, these 3 types of encoders, you can see the gap is getting bigger and bigger. So that is a good indicator that if you have higher resolution, the savings is going to be increased. Okay, so another thing is that the rate saving change with content, and this is also the case that we observe in our study, right? So here I randomly picked like 3 content out of the testing, and then you see the behavior of the rate distortion curve could be very different, but I would say we also observe a few cases that it's even more than this. Some of the content, you basically don't have significant savings from one encoder to another, but for some other encoders, you get huge gap between different encoders, right? So meaning that this saving is going to be highly content dependent, right? So that's another thing that we can talk about. Right, so the next comparison is about computational complexity. Right, so of course, this is again based on the encoder, the setting that we're choosing here. We're using AVC as the baseline. So basically, we do the compression and measure the time, how much time we need to do the AVC comparison, and then use that the unit to compare with. If you use AV1 complexity as 1, and then HEVC is about 4 or 5 times more complicated than AVC, but AV1 is hundreds of times more complicated, right? So if you do this kind of comparison, you will figure out that AV1 is probably 100 times or more complicated than HEVC. And of course, people are improving, right? So AV1 people and the software, hardware, algorithm optimization in order to improve the speed. But this is what we get for the current testing software we have at this point. Right. Okay, so of course the next question is, just now I'm showing some result using SimPlus as the quality measure in order to measure rate savings. Of course, you're saying that probably if we use a different quality measure, then maybe the bit savings is going to be a bit different. So we did the same thing for SimPlus, for PSNR, and the VMAP. In this case, I'm showing 3 tables, all of them for 4K UHD content. Right, so if you look at the bitrate saving tables, actually it's a little bit surprised to me. Actually, all 3 methods give you something kind of similar. Right, so all of them are showing that AV1 performs better than HEVC quite significantly in this case. Right, so probably more interesting is if you compare SimPlus with VMAP, which is the quality metric by Netflix. They are surprisingly very similar to each other. Right, so for example, if you look at AV1 versus HEVC, both of them about 30%. And AV1 versus AVC, right, so it's about 64, 65%, right? So they give you quite similar result. But the real question here is to ask which quality metrics is a better way to measure, to evaluate a video encoder. This is not the right way to evaluate. This is a way to evaluate encoders, but this is not the right way to evaluate video quality metrics. Right, so actually, for video quality metrics, you're thinking about a lot of other things. Right? So for example, you have a lot of desired properties, desired features from a good video quality metric you want to use. Accuracy is one thing. Accuracy means that your correlation with mean opinion score. Right? So that's the straightforward test of your accuracy. And speed, and you want this to be run in real time. And you want it to give you right precision in the sense that it gives you, whether it gives you very precise measurement at each pixel, right? So the finest precision you can imagine at each pixel, you give me a quality number, right? Or at each frame, or each second, or each hour, right? So that kind of granularity is something you care about when you do comparison, right? So also you want this metric to be easy to understand, and it has to be doing. This is very, very useful. It has to give you meaningful comparison across resolution, across dynamic range, across frame rate, and across different devices, right? So if you have the same video you watch on the TV or cell phone, you're going to get different experience. But you want the quality metric to tell you that. And also across different resolutions. So for example, in the comparison we have here, we kind of separate the resolution, right? So we separate the evaluation for 540, 1080, and 2160 into different sections of comparison. But actually, it is very important to compare the scores across these resolutions, because only when you have something like that, you can do some very useful applications like per title optimization, when you have the chance to choose not only bitrate but resolution, right? So, okay, so we have other things. So, for example, if video are not aligned with each other, if you don't have spatial and temporal alignment, then it's very hard to use all these metrics, and it has to be versatile. So basically, this is because I'm from SimWave, and we're producing this SimPlus metric, and these are the property actually only SimPlus has, right? So, and we think this is a very, very important must-have properties as a quality metric when you use them to evaluate video encoders, right? So, fortunately, we're going to have another. I'm going to have another talk in the afternoon in the video encoder session, just talking about video quality metrics. And at that time, I will have more chance to explain why I think these things are super important, right? So, okay, so that's basically what I want to talk about. I think instead of reading all these things, I would rather take some questions. Thanks.
Okay. Thank you, Sal. All right. I'll start with Dan, and Dan, you can handle the mic.
Yeah, thanks. Thank you for your talk. I have a couple of questions, related questions. So first of all, when you say that you compare AV1 against HEVC and AVC, against which particular codec you do that? Like X264 or X265 or?
X264, yeah, so I mentioned, so it's X264 and X265, yeah.
And, okay, and what are the command lines, at least like some important features, like which preset do you use?
Yeah, preset is very slow preset. I said that, yeah, so it's
very slow.
Preset.
Okay,
yeah,
okay.
Yeah.
So
it's not the slowest. It's almost the slowest.
It's almost.
Yeah. So it's. I would say. So doing all these compressions is really painful, especially AV1. It takes a day to compress a 10-second video. That's really. Yeah. I do expect that. Hope that.
No, because using this preset.
AV1 speed. Yeah.
Sorry. Using this preset is very important how actually you define the command line, and it could be good to see the command line itself, because if you properly define like the preset tools is not enough. You need also to put additional stuff, and maybe preferably use placebo instead of slow preset. And if you, can you get to the table with the complexity? You have a table with the complexity aspect.
Yeah, so it's 100 times faster than
next one, yeah. It was so, but if I look just at this one, yeah. So if I just look at the difference in complexities, I see that these settings are not optimized in favor of X264 and X265, because the difference between AVC and AV1 should be much larger, because X264 is really fast. So it's not. I think it's much. The number should be much larger. So I think it's important to show the command life itself, because it's critical to such comparisons such as this.
So basically what we do, we didn't do much. All we do is to just choose a very slow preset, and that's X264 and X265. I think these are probably better questions for 265 guys, and X265 guys, they can explain exactly what's in that. Very slow. What very slow really mean, right? So.
Also, perceptual, it's like more.
Yeah. Very interesting talk.
Yep.
You mentioned you did some subjective analysis. Can you share with us what that?
Yeah. So we do have a lot of interesting observation, but we haven't finished. Like we plan to have 30 people at least for each video to watch each video. We don't have. So we haven't finished that. So that's why I don't want to. Show the result. I do have some interesting observation over there.
Any preliminary results? Does it support the SimWave measurement, or is it slightly different?
Yeah. So basically, what I can say at this point is, it does have much better correlation with SimPlus than VMAP. That's what I observed. So that's something for sure. And PSNR is even worse. Right? PSNR is really a bad metric for testing. It's kind of a similar. I think I still need to draw that conclusion after I finish with subjective tests. Yeah.
So I take it that these were done with fixed QP, no rate control.
I'm sorry?
Yeah. So the simulations were done with fixed QP, no rate
Right.
control.
So we use CRF. Yeah, we use CRF. It's not like, so that's the thing. So actually Dan just mentioned earlier that if you include rate control, then you can change the picture a lot. We observed that before as well. So if you use a different rate control strategy or you optimize for different quality metrics, you could end up with a very different conclusion. Right. So that's why I said this is just about this particular setting, comparison for this particular setting. Yeah.
When you compare the metrics or compare the content, isn't there a purpose in also noticing where the codecs behave, sections where it behaved the worst, instead of just showing an average SSIM or SIM over the entire clip?
Yeah, so, yeah, right. So, of course, it's a 10-second clip. So, SIM Plus is going to give you curves. It also can give you local quality measure. So that's the thing. Actually, that's the kind of the things I want to talk about in the afternoon's talk, right? So that's about how the video metric, quality metric behave.
Take one more question.
Thank you.
You mentioned at the beginning that you looked at other implementations of AV1, Chinese library, I think you mentioned. Do you have any preliminary results of the quality or the computational complexity of that library?
I'm sorry, I don't really hear the...
Oh, at the beginning you mentioned you looked at other implementations of AV1 besides the one I think you have here, a Chinese one you mentioned?
That's AVS2, that's not AV1, that AVS2, that's a Chinese standard. Right, so I just want to mention that we test that as well because some people told us that's actually pretty impressive codec encoder as well. So we tested that, and it's also open source, and actually it gives you so far we observed quite impressive result, but we don't have the conclusive result yet, so I don't want to show numbers at this point. Just want to draw people's attention. Right, there's another one that's rising as well.
Okay, thank you. Thank you for the talk and the questions.